We promised you we would look at each of these layers in more detail, so that's what we're going to do right now. We're going to start off by focusing at the very top. So we're going to work top down. At the very top, we see the application layer. Now, at first thought, you might think the application layer is your web browser, your email client, something that's going to give you connectivity to a network resource or some other device. But Dan, is that really what it is?
Let's debunk that. Our web browser, let's say it's Internet Explorer or Firefox. That's an application. I think we can all agree. But this model that we're seeing here is representative of a protocol suite and everything that happens in a protocol suite. So there could be some tie-in between an application and a protocol suite, but we wouldn't want to muddle the definition here. An application is an application, a protocol suite is a protocol suite. So Raymond, it seems to me like we do need some on and off ramp sections of our protocol suite so that they can get information off of the protocol suite and into the application that needs that. That's really how we might conceptualize the application layer. It is the hook. It is the communication glue to which it binds itself to the operating system or the application that needs to use the protocol suite to do some communication.
And then we move down to the presentation layer. Now, when I think of the presentation layer, I think of a gift that I might receive on my birthday. What do I have? I have this really nice wrapping on it to make it look really good. It's all about presentation. We have to make sure here that one device is communicating properly with the other device. We can't be using EBCDIC format and ASCII format, right? We have to come to a common understanding and present traffic in the exact same way.
I really struggled with something that I think relates to the presentation layer. Raymond, have you seen the Jodie Foster movie based on Carl Sagan's book, Contact? The movie is called Contact. Here's what happens. We've got aliens, they're communicating with us. Aliens. We finally found some aliens, okay? And they're communicating to us this signal. And they just happen to be able to take the signal and interpret it with a regular TV monitor. You know, I really struggled with that. Because how are we going to know how to interpret the alien signals? Yes, it's going to be ones and zeros, but it's going to have, as Raymond said, some structure, some standards. How do we present that data? I never got over that with that entire movie. And we have to understand the need for that. If I communicate an image, I need that image to be like a JPEG or a bitmap. Raymond, what are some of the presentation standards for audio?
Some of the ones that come to mind are MP3 and WAV.
So we have these constructs already, and our protocol has to be able to prepare us for what data is following and the right way to read that data. This is image file, this is an audio file, and this is the format that we're using to communicate that. All right, so Raymond, we're going down this, as we can see. Okay, application, presentation, session. What happens at the session layer?
Well, the first thing I want to ask you, Dan, is how many web browsers do you have open, or how many tabs do you have open in your web browser?
Well, I really don't have that many right now because I have to be dedicated to this presentation. I'm not able to multitask. But if you were to ask me that outside of this environment, I might have 15 web browser tabs open at any given time. I might be approving people's time. I might be logged into webmail. I might be surfing the web on Google. So I've got a lot of web browser tabs open on a typical day-to-day basis.
So our session layer is going to be responsible for keeping track of what's going on here. Dan has all these different sessions that are open. He has one web browser, 15 tabs, let's say. He's going out to all these different sites Well, this session layer has to know, when that traffic arrives back, which tab does it have to go to? Because if it goes to the wrong tab, it's going to the wrong place. Dan does not want that web traffic that's coming back from Cisco.com to end up in his email. So this session layer has to keep track of things. And Dan, how is it going to keep track of that?
Well, there are numeric values that are encoded with protocols that live here, okay, that are communicating and differentiating. We call those port values, actually. We call those port values, and we'll see examples of those. Why we care about this is actually one of those values that firewall could be looking at, or an access control list which could filter communication based on the ports. But let's go down deeper. Transport layer now. The transport layer, I'm concerned about conversations and the ability to ensure the data got where it needed to be. Back decades ago, when we were in the formative stages for the network technologies that we're dealing with, we were very paranoid about making sure the data got there. And so, Raymond, if I am in need of knowing that data got to its ultimate endpoint, the intended recipient, what mechanism could I use to ensure successful data delivery?
I would need to use a reliable transport layer protocol. TCP is reliable. Dan, if I did not need reliability, would I use TCP or could I use something else at the transport layer?
I could. If I didn't need it, I could still use it. But then I'd be getting all of the bulk along with TCP that I may not need. TCP is a rather bulky protocol. It's not to say that it's bad. We use it heavily. But there's a lighter weight protocol that doesn't give us reliability called UDP. So we now see something quite important. We see that we get choices when engineers are choosing the protocols that are involved in the communication. We're not in that place where we choose to do TCP or UDP. But we have to understand that protocols and how protocols follow this tree structure are established. And the way that they're built is based on the needs of what runs on top of them. So the transport layer gives us a lot of flexibility, reliable or unreliable. TCP for the reliability, UDP for the unreliability. Raymond, let's go back to TCP for a moment. Does TCP go through some extra formality before we could even send some data across?
Yes, it's going to do what is known as a three-way handshake. It actually has to set up an established connection between the two end devices. So there is actually this formal communication process. I'm introducing myself to you, Dan, before we actually start talking. So I might come up to you in public and say, "Hi, my name's Raymond Lacoste. Nice to meet you. Would it be possible for me to actually talk with you?"
And I'd say yes. And I'm not talking with anybody else right now, so let's start up some communication.
So then I would then be really excited that Dan is going to talk with me. So we have done this three-way handshake to establish that communication. That's how we get our reliability, because we know that we're communicating with each other. And there's a more involved in that process, and we'll see that here as we go through this course as well. Now, the network layer, as we move down one more, we're actually going to learn about a lot of different functions and a lot of different services at this network layer. And we're going to spend a lot of time talking about a device that resides at the network layer. Dan already mentioned that device with me earlier. We said it was a router. This router is giving us the ability to connect two different networks together. At this layer of the OSI model, Dan, we're actually going to find addressing as well, aren't we?
We are. And addressing is not unique to this layer. We can have different addressing. In fact, we'll have addressing at layer 2, but there's a kind of addressing that lives at layer 3. First, we would call it hierarchical, because when we're a layer 3 addressing structure, the first part of it, like our phone number, tells us where we are. And then the second part is our unique identifier within that space. And we'll in fact talk about 2 different logical addressing schemes in this course. IP version 4 and IP version 6. They're both logical addresses, and it's strange to call it logical. We start to think, well, did Mr. Spock from Star Trek call these out by name, calling them logical? No. Logical is in the fact that they are not physical. They are assigned after we connect up. They are assigned values based on where we are. They're not inborn in the network interface cards themselves. And that's what makes them logical. Although when you learn more about them, you might think that they're anything but logical. But they're really an important thing. We'll spend a lot of time on IPv4 addressing and a little bit on V6 addressing in this course. Okay, so Raymond, routing takes place at layer 3. Routers live at layer 3. IP addressing takes place at layer 3. Let's move down towards another layer that's deeply important to us here, and that's layer 2.
The data link layer is more important than we actually realize. The physical layer is all about that physical connectivity. There's not a whole lot of intelligence going on down there. So the data link layer has a major responsibility, and that is making sure our traffic is formatted properly for the actual media we're using at the physical layer. So the intelligence is up here at the actual data link layer. Now, we're going to find a specific device at this data link layer. It's going to be a switch, our layer 2 switch. Not the multi-layer switch we talked about. The multi-layer switch, that's at the network layer. At layer 2, we find that layer 2 switch. And then we're going to have addressing here as well when we're dealing with our different types of connections. Specifically, let's talk about Ethernet connectivity. We're talking about Ethernet connectivity. We're going to have certain addresses listed for our communication. What type of addresses are we dealing with here?
At layer 2, the address type that you're going to see for Ethernet is the MAC address. Now, it doesn't have to do with Apple products. It has to do with media access control, which is a fundamental feature and operation that happens at the data link layer. Media access control is how do we get a word in edgewise in a network. You remember the bus topology? There were media access rules that help us navigate the challenges of the bus topology, which is shared, and we have to back off when someone is talking. So we have this address that comes from that functionality called the media access control address. That's the MAC address. It is a 48-bit address that is burned in to our Ethernet cards. We call it a burned-in address, and it's burned into the silicon. It actually can be rewritten. So it's not that burned in that it's immutable, it's unchangeable. No, we in fact can usually change it inside of our cards. But layer 2 switches are concerned about where these MAC addresses live, and we'll see that very nature later on in the curriculum. They'll go, this MAC address is there, this MAC address is there. And so that's the primary need for a layer 2 switch to work, whereas a router has a different challenge. It needs to know where this logical IP network lives and where this logical IP network lives. And that's a layer 3 function. And we can start to see those differences take shape, and our understanding of the OSI model is giving us a deeper ability to work with these technologies and start to really learn about them.
The very bottom layer is the physical layer. And as I mentioned before, there's really not a whole lot of intelligence going on here. What are we doing? We are getting the actual data on the network wire. We're sending bits, ones and zeros, across some type of physical wire if we're physically connected, or over the radio waves if we're dealing with wireless. So we are dealing with electrical, mechanical, procedural things down here that are going to give us the actual physical connectivity that we need in our environment.